Viewer to part 6 of the TitanBot series. In this episode, we'll be building the Vetronics Deck. This will sit at the back of the TitanBot, between the two rear gearboxes. This deck makes space that would otherwise be wasted available for the buck converter, the custom power hub, and the Arduino Nano that need to be positioned on the robot. So here is our part. We have a hole through the trunk that will be used for mounting a switch and is a conduit for the main power wire that comes from the battery. And we've got a couple of anchor points for shell components that we will add later on in the series. All right, so let's get started. Let's create a new body and create a sketch. So put that sketch on the XY plane, and we're going to just zoom out so that we can see the extremities of the x-axis there. Grab the polyline tool, and we're going to create a simple shape here. Right-click to clear our tool. We're going to close the shape in a minute, but first we're going to make the top and bottom equal to each other. And we're going to make this shape so that it is symmetric with respect to the x-axis. All right, so I'm coming up here. I'm going to grab this Create Arc by 3 Points tool. I'm going to left click on the two endpoints here, and I will create a fairly gentle arc like this. And I'm going to constrain this arc to 302 millimeters. It's a really nice, gentle arc. Now that we have that, we're going to constrain the height of this shape to 94 millimeters. And we will set the width of it to 72 millimeters. And we have got 1 degree of freedom. That's its position along the x-axis. So we will make the top line so it is symmetric with respect to the y-axis. And now our shape is fully constrained. So let's close out of that. And we're going to pad this shape out to 3 millimeters. All right, so now we're going to add the trunk to this shape. So let's just give ourselves an isometric view, and I'm going to click it on the top part of this pad. And now we're going to begin as we did a moment ago. We're going to create a similar shape around the X and Y axis. Right click to clear my tool. Again, symmetry with respect to the X axis. We're not doing symmetry with respect to the y-axis, but we are going to use the external geometry reference tool and bring in this arc that we just created. And now we're going to create a line segment that's coincident with this line. So we've got that, and now we are going to make the ends of our box here coincident with this arc that we've created. Now that we have done that, now let's constrain some of these. So we'll constrain the top here to 70 millimeters, and we will constrain the edge here to 24 millimeters. All right, so that's all we need to do for this. We're going to close this out, and we're going to pad the trunk out to 27 millimeters. So there's the trunk complete. Now we're going to add some mounting holes to the bottom of this. We will use PT screws to attach this to our MDF mobility base. So create a sketch on the top of the trunk base, and we're going to bring in the edge of this arc. But this time we are going to toggle our construction geometry, and we're going to grab the point tool. I'm going to create a single point sitting on that arc, and we're going to make it so that that point is coincident with the x-axis. So there we are. We're going to use this point as a reference in a moment. We're going to create 2 circles now. These are going to be screw mount points. So we will set these 2 holes equal to each other, and we will set their diameter to 2.8 millimeters. We're going to make it so that these holes are separated by a distance of 47 millimeters, and we're going to offset them from the edge of the trunk by 13 millimeters. All right, so our holes on the bottom of the trunk are fully constrained, so we can close out of this, and we are going to pocket these holes to 12 millimeters. All right, now we're going to create a conduit through the middle of the trunk. So this is going to be for the power wire that comes from the battery. We're trying to keep it separate from the signal wires so that we don't have any interference. That's probably somewhat unavoidable. But this is also going to give us a convenient position to put the power switch so it's accessible from the back of the robot. All right, so we're going to grab the oblong slot tool here, and we're going to create a slot, okay? And we're going to constrain that slot so that it is 7.5 millimeters from center to center of our slot. We're going to give this slot a radius of 6.6 millimeters. This was a size that was best able to accommodate the switch that we're using on this robot. And we are going to position it with respect to the bottom of the trunk. And so we're going to click on the internal part of that, and we're going to set that to 11 millimeters. Okay, so our slot is fully constrained, and we can close out of this, and we're going to pocket this slot all the way through the trunk. So 71 millimeters clears the trunk. And now we've got the basic shape of our deck. All right, so now we're going to add some mounting holes in the top of the deck. So we're going to rotate this part over so that we're looking at it, and we're going to create a sketch on the top face of the deck. First thing that we're going to do is create a couple of mounting holes for the Arduino Nano. So we will make them vertically constrained with each other, and we will set the diameters equal to each other. The diameter on this will again be set to 2.8 millimeters. And we're going to set a distance between these two holes of 41 millimeters. And then we will position these holes with respect to the back of the platform. So we're going to offset these two holes from the back of the platform by 13 millimeters. And we will bring it down from the edge of the platform here by 20 millimeters. All right, so these holes for the Arduino Nano are now fully constrained, and we can close out of the Sketcher workbench. We're going to pocket these holes. And next we're going to create some mounting holes for the power hub that we need to manufacture for this robot. So we're going to create two holes. These ones are offset from each other, and we're going to start by making sure that they have equal diameters, and we're going to set the diameter on them again to 2.8 millimeters. Now that we've done that, we're going to set the distance from center to center between both of these circles to 55 millimeters. And we're going to space them apart from each other vertically with respect to our current view to 15 millimeters. All right, so 15 millimeter separation, so these holes are spaced properly. Now we're going to position it on the platform with respect to the bottom right corner of this platform. So we will make it so that it is 5 millimeters away from the back of the platform. And we will roughly position this in the center of the board by separating it from the edge by 33 millimeters. All right, So this will nicely accommodate the custom power hub that we're going to build. Our sketch is fully constrained, so we can close out of this and pocket these holes. Now we've got two more boards that we need to accommodate on this deck. So we're going to create another sketch, and we're going to create two holes down in the bottom right corner here. These are going to be mounting holes for the power splitter. As the power comes in from the battery, we need to split it between the buck converter, and we need to send over a line to the motor shield on top of the Arduino Uno. So that's going to be this little breakout board here that we construct. I'm going to separate these two mounting holes by 15 millimeters, and we're going to position this board location with respect to the bottom right hand corner according to our current view. So we're going to give ourselves a distance of 5 millimeters from the back, and we will give ourselves a distance from the edge of 7 millimeters. All right, so those mounting holes are now properly in place. Now we need to create some mounting holes for the buck converter that we'll be attaching. So we need two more circles. Set the diameter of both of those equal to each other. And as before, we will set the diameter of this pair of holes to 2.8 millimeters. Now these holes have a vertical distance between them of 17.5. This number was taken by just measuring the holes in the buck converter. And these holes are separated horizontally by 30 millimeters. So that's the basic mounting pattern for the buck converter. And now we are going to align the buck converter with respect to the edge of the board. So we're going to give that a 6 millimeter distance from the edge. And we're going to separate it from the bottom edge of the board by 32 millimeters. All right, so that fully constrains the two sets of holes that we needed for those parts, and we can close out of this and pocket those. Okay, so we have now set up the top of the deck for the electronic components that we're going to be mounting there. Now we're going to rotate around so that we can view the bottom of the deck, and we need to create some anchor points for some of the shell parts that we're going to be building later on in this series. So we're going to reference this arc at the front of the deck, and I'm going to use this tool here to reference our arc. I'm going to continue to build this out using the polyline tool. And we're also going to need to reference the edge of the boards here. So let's reference the top and bottom edge. And we're going to create a fairly rough shape to start with. So we're going to use the line tool, bring that out, do the same up here. The polyline tool tries to continue the arc, so it's not very helpful for what we're trying to do. Okay, bring that out. There we are. So there's the basic shape that we're going for on the top. We'll constrain that here in a moment. And there is the shape on the bottom. Okay, so we're going to make the edges of these shapes so that they are equal to each other. I don't think I actually clicked that. Let's try that again. All right, let's try that. There we go. All right, so the equals constraint has been applied. We are going to set this so that this is constrained vertically We want this one to be constrained horizontally, which it already is. And we want, and that one's constrained horizontally. Let's constrain, we're not going to constrain that one vertically, we'll leave it as is. We will modify it as we go. All right. We're going to take these two portions of these mounts that we're creating and we'll set them and make them equal as well. There we are. I'm going to Control Z that because that's not quite what I was hoping for. I wanted that one and that one, and I want to set them equal. Good. That was the intended result. Okay. So now we are going to constrain these parts. All right, so I'm going to set the overall height of these with respect to our current vertical. Set that to 15 millimeters. I'm going to set the width here at the bottom to 10 millimeters. I'm going to set the internal part here to 7.5 millimeters. And we're going to set the height here, or the thickness of this part, to 3 millimeters. So with these constraints in place, we've now fully constrained the bottom mount, but we still need to constrain the height of the top part of the mount here. Set that to 15. And let's see, what do we still need to constrain here? So it looks like this needs to be set equal to the bottom one here. So we'll click on both of those and click equals. And now both of our mounts are fully constrained. All right, so once we've got that, we can exit out of the Sketcher workbench. And we're going to pad this shape out to 5 millimeters. So that gives us these mount points on the edge of our deck that we can use for attaching parts of the shell. Now we need the holes for attaching those parts of the shell. So I'm going to start over here on the right hand side and create a sketch on that face and get a nice clean view of that. I am going to reference the inside edge here and I'm going to create a circle. We'll set the diameter of this circle to 2.8 millimeters. Then we're going to lock it, constrain it with respect to this bottom corner here at 6 millimeters. And then we're going to constrain the distance of this shape from the bottom of the platform. And we'll constrain that to 2 millimeters. All right, so that hole's being constrained. We can close out of the sketcher and we can pocket that hole. And we're doing this on the back face here. I deliberately made these back faces flat, creating a circle on the curved face of the deck would have required us using a different workbench. So this is just a simple way of doing it. Again, I'm going to reference that edge next to the mount. I'm going to create a circle. We will set the circle's diameter to 2.8 millimeters, and we will make sure that it's set a distance of 6 millimeters from the inside edge, and we will make sure that it is 2 millimeters from the bottom of the deck. All right, so that's both front-facing, or I guess rear-facing, mount points finished. And now we need to create the anchor points for the shell that attaches to the edge of this deck. So we're going to create a sketch on the edge. We'll create a circle right here in the center. And we're going to reference this short edge here of the mount. Let's set the diameter of our mounting hole to 2.8 millimeters. Again, because we want to mirror the 2 millimeters that we set for the other hole. We're going to set that to 2 millimeters from the bottom of the deck. And then we're going to come over by 5 millimeters. And there we go. All right, so the shape is fully constrained. We can close out of that and we can pocket it. And we'll do the same on the other side. So we are rotate around, click on that face, create a sketch, create a circle, reference that inside edge, give it a diameter of 2.8 millimeters, and then constrain it so that it's 2 millimeters above the deck and 5 millimeters away from the edge of our mount bracket. All right, so we can close out of this and pocket that hole. And just check our work here. All the holes went all the way through. All right, so there is the Vetronics deck that will sit at the back of our TitanBot.